Hello. The point 2, is placed on the graph below. Name another point so that when a line goes through it and 2, it is parallel to the given line. All right. Well, let's do this the easy way. Parallel lines have the same slope. So if I put a dot right there, it appears to me that my slope is -1 if I go up 1 over 1. So why don't I just go up 1 over 1, and we can say 1, 1 is a point that we can choose. In reality, there's an infinite amount of points that we choose, but since I noticed that the slope is -1, I'm just going to pick that point. I can also pick that one, or that one, or that one, or so many more. Perfectly round points, as you can see. Today we're going to talk a little bit more about parallel and perpendicular. This meme made me laugh because it has nothing to do with anything, and it's just a picture of a mallard, and it says the slopes of perpendicular lines are opposite reciprocals. It's not good. It's just a duck, a mallard. Meme, yes. Oh, yes. Oh, more people are saying things. Okay. We're going to talk about finding distance between points and lines, which sounds weird, but that's what we're doing today. If I give you a point and a line, the distance, so here's a point, here's the line. I actually said that backwards, didn't I? Some of you might be like, well, maybe that's the distance if I were to get a measure, or that's the distance, or that's the distance. How will I know what the distance is between a point and a line? It's simple. If I give you a point and a line, so here's a line, and I'll put the point there. Okay, you're going to create a line that's perfectly vertical or perfectly perpendicular to this line, and the distance is going to be that perpendicular line right there. It's got to be perpendicular. Okay, it's kind of like when you go to the doctor and they measure your height, you have to stand perfectly tall. You're perpendicular to the ground. You create a 90-degree angle from the ground. You're not going to stand up sideways and have people and doctor be like, hey man, that's not how I measure your height. Hey man. And you're like, I'm just kidding. It's not like that. It's not like that at all. Well, they don't. So it's not like that. Skipping you. And we're going to get right to doing examples. And I'm skipping you. If I want to do this, there's actually a several step process. And so let me open up a new screen and let's write those steps out. I wish I could type, but I can't. Or can I? What if I right click on it? Nope, no typing. Not today. Not today. If I want to find the steps involved in finding the distance, I can find the distance. What Disney movie is that? I actually don't remember. I know he says I can go the distance. All right, there's steps. First step is you need a line. Okay, so I'll be like, this line right here, blah, blah, blah. Okay. You need to find the line perpendicular to it. And it has to go through a specific point. We'll talk about that. So it'll be like, here's a point and here's a line. Okay, or something along those lines. You need to take that point you need to take that point and find a line perpendicular to this line and going through that point, which we've done before a couple times. Once you do that, you will have two equations. You're going to hate this part. You're going to have two equations. You might have to, goes find the line perpendicular. That's my and symbol. Sorry, that's my and symbol. You have a line and a point. Okay, you find the line perpendicular to that by doing negative reciprocals, and the rest we'll go over it again, and I'll probably remind you of the website that we've been using just to save a little bit of time. So now you have a line, and now you have this line. What we'll have to do probably is solve a system of equations, which we've done before. Was it Hercules? I can go the distance. I'm a Greek god. I can go the distance. Once you saw this system of equations, then you use the old tried and true distance formula. All right. I'm going to get a piece of paper. Did I misspell something? You put the letter E up there. Usually when you guys put letters up there, it's for mocking me and making me feel bad about myself. Sports? What? All right. I'll give that another minute or two. I'm going to switch over to the camera. Not the Camilla, but the camera. Yes. Yes. Oh, come on. All right. I think that's enough time for you guys to write stuff down. If I were to find the distance, I feel like I'm missing something. I am. I'm missing a... I'm not missing it. I accidentally moved ahead. All right, let's do an example using... we'll just do one of them because I have problems on a video that you guys can just rewatch that over and over and over and over and over again if that's what your pretty little hearts desire. Let me switch over to... it's not letting me switch over to my camera here. That ain't good. I'm gonna do what I did yesterday and go out of the meeting and join back in. Be right back. I'm back. I'm back. I'm back. I'm back. And I can switch cameras. And I'm going to present this screen still. So, make sure you're toggling between the screen that I have and the camera, because this involves quite a bit of writing, and I want to make sure that you guys have a nice, clean thing to watch, because you know how this works. My handwriting on my Chromebook is a god-awful mess, but, on regular paper, it's pretty fine. So look at the presentation that I am presenting and peep it, which means look at it for those of you who don't understand slang. We're going to do just one of them, like I said, just one of them, and we'll start out with problem 4. Problem 4 wants me to find the distance from P to L. So problem 4. All right, I have a line called L, and I have a point called 310, whatever that is. Okay? This is what I have to do. I have to, let me get a different marker pen. I have to find the distance between the line and the point 310. So this is what I need. I need a line perpendicular to that. Well, in order for me to find the line perpendicular to that, I need to find this line right here. So how do I find this line right here? Well, it gave me 2 points for line L. Line L had the 2 points 4, 3 and negative 2, 0. So the way I'm going to find the line for that is I'm going to first find the slope. So I'll do slope-intercept form. Slope-intercept form is y equals mx plus b. I have to find the slope to this. So the way I first find the slope to this is I call that x sub 1, y sub 1, x sub 2, y sub 2. And I'm going to find the slope for line L. So my slope, and sometimes when people are finding slopes to specific lines, they put a little L underneath it. Not that, or like as a subscript. Not that you have to do that, just some people do it and you're in geometry, so why not start now? It's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. My y sub 2 is 0 minus my x sub 1, which is 4. Make sure you always have a minus in the middle, which is funny. I've heard of a Malcolm in the middle, but a minus in the middle, that's, that's different. So x sub 2 is on the bottom. That's negative 2. Negative 2 minus, did I screw up? I did screw up. That should be a 3 up there. That should be a 3 up there. Might be, y'all. Might be, everybody. 0 minus 3 and negative 2 minus 4. That's going to give me negative 3 over negative 6, which is just a half. So for line L, what I have so far is y equals mx plus b, which is 1/2 x plus b. I need to find b. How can I find b? Take one of these points and plug them into what I have so far, and that'll give me by b. So if I'm going to look at negative 2, 0, and I'm using negative 2, 0 because it has a 0 and it's going to make life a whole lot easier. If I'm going to look at negative 2, 0, negative 2 is an x value, 0 is a y value. So the y value is 0, and negative 2 is an x value. So that gives me half of negative 2 is negative 1 plus b. B is going to equal 1. So when I put all that together, y equals half an x plus b. So line L, plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. Y equals half an x plus 1. That's line L. Now what I have to do, so step 1 was find my line L. And you're like, that's only step 1? Yep. Step 2 is to find a line perpendicular to L and going through that point. So the line perpendicular to L, if it's going to be a perpendicular, It's going to have a perpendicular slope. So if the slope up here is a half, then the perpendicular slope is going to be a negative reciprocal, and the negative reciprocal of a half is -2. So what I have, so for the perpendicular line, and we'll call this, I don't want to call it line P. For the perpendicular line, what we have so far is y equals -2x plus b. I need a b. Well, how did I find b before? I plugged in one of these points. So I'm going to plug in the only point that I was given specifically for this line. And the only point that I was given was 310. So my y value is going to be 10. My x value is going to be 3 plus b. So I have 10 equals -6 plus b, add 6, b is 16. So putting all of that together, I have y equals -2x plus 16. So this green line right here that you can barely see is y equals -2x plus 16. That was step 2. Pretty dope, huh? It is pretty dope. You just don't even get how dope and lit it is, fam. Step 3 was solve a system of equations. So I have that equation right there, and I have that equation right there. I'm going to write it as a system of equations. So y equals 1/2 x plus 1, and y equals -2x plus 16. Now, you learned how to solve systems of equations in 3 ways: graphing, substitution, and elimination. To me, this screams elimination, because if I multiply the top by 4, actually, now let's just do substitution. If y equals this guy and y equals that guy, then they equal each other. 1/2 x plus 1 equals -2x plus 16. I'm going to add 2x to both sides. That gives me 2.5, but I'll write it out as 5/2 x plus 1 equals 16. If I subtract 1 from both sides, I get 5/2 x equals 15. Instead of dividing a fraction, I highly suggest that you multiply the reciprocal. So I'm going to multiply both sides by 2/5. When you have a whole number multiplied to a fraction, divide the bottom number. 15 divided by 5 is 3, and then multiply that to the top. X will be 6. How do I find my y? Plug it into one of these equations. How about that one? Y equals -2 times 6 plus 16. Y is going to equal -12 plus 16. And y is going to equal 4. So what we get here is the 0.64. That, ladies and gentlemen, was step 3. Oh, if you're writing something in the chat, I can't see it, so. Step 4 is use the distance formula. Use the distance formula on what? Well, what we just found out by solving the systems of equations, we found out that this point right here is 6, 4. This whole time, my job was to find the distance between that point and that point. So now step 4 is going to involve me taking that point, 6, 4, that point, 3, 10, and using the distance formula. Distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared inside of a square root. My 2 points, once again, and I'll rewrite them, are 3, 10 and 6, 4. Yeah. I'm going to call u x sub 1, y sub 1, and I'm going to call u x sub 2, y sub 2. So I have d equals the big square root of x sub 2, which is 6, minus x sub 1, which is 3, squared, plus y sub 2, which is 4, minus y sub 1, which is 10, squared. That becomes 3 squared. That becomes negative 6 squared. That becomes 9. That becomes 36. And that becomes the square root of 45. What's the square root of 45?
Working on that.
Oh my gosh, Siri.
Something went wrong.
I'll say.
Please.
What's the square root of 45? Yo, Santi, you right, dog.
1 moment. Still working.
Okay, well, I don't know why she's giving me issues, but there you go. All of that. All of that. That's how you find the distance between a point and a line.